Well, welcome to Chapter 11. Chapter 11 is all about capital budgeting. So we'll talk about what that means. It's kind of the next step from Chapter 10. So that makes sense, obviously. And so we're going to talk about what you see in the screen right there. There are several methods involved in capital budgeting. And we're going to go through and talk about each one and what that means. So what is capital budgeting? Think of it as the decisions that companies make when it comes to what to acquire in terms of long-term fixed assets. So these are generally very expensive assets that will last a long time and that cannot easily be undone. It'd be the example of building a factory, building a new store, buying large equipment. Those are all examples. Something that's expensive that we purchase will last a long time. It's not easy to undo the calculation or the decision, and so we have to make sure that we make the right decision. And that's really what this chapter is about, is doing the calculations to figure out if we should go about investing in a new project or whatever that might be. Okay, so the steps in capital budgeting, and we'll go through examples, of course, is number one, estimate cash flows both in and out, inflows and outflows. And this chapter kind of just introduces us to the capital budgeting process. The next chapter, chapter 12, will kind of get us going with what exactly is the process for calculating cash flows. So for this chapter, they'll give them to us. We're going to focus more on the computations of how to come up with the capital budgeting calculations. But in the next chapter, we're going to come up with the cash flows. And then we talk about riskiness of those cash flows. How certain will they happen? How much risk is there in them? Figuring out what the appropriate cost of capital is, which we all know kind of just came from the previous chapter. Then we find NPV, which stands for net present value, and or IRR, which is the internal rate of return. And then we learn what the decision guidelines are. If your NPV is greater than 0, we would generally say, yes, I will accept that project. If the internal rate of return is greater than the WACC, then again, yes, I would generally accept the project. Okay. Now, part of the chapter talks about what is independent versus what is mutually exclusive. Okay. So independent means cash flows of one are unaffected by the acceptance of the other. Mutually exclusive means if the cash flows of one would adversely impact the acceptance of another. Okay, so a great example that I like to use with this is, let's just say in Sioux Falls there is one Home Depot. Okay, there's one. And it's more towards the west side of town, off of I-29 north of 41st Street. Let's just say that the folks at Home Depot corporate think Sioux Falls is big enough that they want to add another store. Right? So if they build an east side Home Depot store, what would happen to the sales of the existing Home Depot? And I think we all know what would happen in the short term. Most likely sales would come down because people who live in Brandon or the east side of Sioux Falls, they'd go to the store that's closest. Why travel across town when there's one just really close to me, right? So most likely in the short term, sales might go down at the existing store, but eventually the sales of both over time will be more than if it was just the one store. So that's mutually exclusive. Cash flows of one negatively impact the other. Independent is, I'm just doing something completely different. I'm Home Depot opening a store in Bismarck, North Dakota, has no impact whatsoever on Sioux Falls, South Dakota, right? That would be more of an independent project. So you have to look at every project you do from that lens, because if this project negatively impacts something else that I've done, I have to adjust the cash flows for that. Okay, and then we have what they call normal versus non-normal cash flow streams. And the way most of the cash flow streams work in capital budgeting is we invest a large amount of money. So the normal is there's an initial negative. I'm going to spend $20 million to build a new Home Depot store, okay, or whatever that number would be. We're going to invest money to buy it, to build a new store, fill it up with inventory, everything we need for a store, hire people, get them trained up, and open, and then start to sell goods. Okay, and then obviously we'll have a whole lot of positive cash flows, ideally after that. Non-normal means there's 2 or more changes of signs. And that might be one that kind of goes with something in mining, nuclear power plant. Let's just say it's mining, and if you're going to start a mining project, you have to get a whole bunch of permits and all that kind of stuff. And most likely, you're going to have to commit some resources or set some money aside in a trust that says when the project is done, you need to go and kind of put everything back together again, right? So there's a negative outflow to get the equipment going and start doing the mining. Positive cash flows as we sell the resource, then a negative cash flow at the end to kind of put it all back together again. So that's a non-normal cash flow. Most of what we'll do is going to be more the normal side. Okay, so let's take a look at all the various different forms of capital budgeting. The first one is net present value, NPV, and this is the formula for it. Now, I'm not a big formula guy. You don't have to memorize formulas necessarily too much. Just be aware that Excel will do this for us, and that's where we're going to go. We're going to go use Excel to do these calculations for us, but it's easier to understand the calculation if I know what goes into the formulas. That's the purpose of me showing this to you. So this is the sigma symbol. Okay, looks like a big letter E. That means sum, and so the N is number of periods, T0 is time. And then what we do is we take cash flows at time divided by 1 plus R, and that might be the WACC, to the power of time. Okay, keeping in mind that projects typically last several years, right? More than 1 year. If it's 1 year or less, I'm not doing this calculation. I'm doing a different calculation. Okay, so that's NPV. So it's the sum of the present values of a whole bunch of cash flows. Okay, so here's an example. We're going to look at projects L and S. Think of L as long and S as short. In year 0, at time 0, today, we're both going to invest $100. This could be $100,000, but just think it's $100. Both projects require I spend $100 initially, and then I get future positive cash flows. At the end of year 3, the project is over. Okay, so this could be like I buy some machinery. I'm going to build or make some product and sell it. At the end of 3 years, the machinery will be obsolete. At that point, the project is done, and I can move on to do something else. Okay, so I spend $100 today, and under these two options, I get 10, 60, or 80. This one I get 70, 50, or 20. So L versus S. L meaning I kind of have to wait to get the big cash flows. S, I get that big cash flow right away. Okay, and we'll use the change in delta. The triangle means change, so we'll look at that later. They gave us the WACC. They said the WACC is 10%. And so in year 0, I've got a negative $100 cash flow. There's no present value. Time 0, we don't have to discount anything. But then conceptually what I'm doing is I'm bringing back all those future cash flows back to today's value using present value of a lump sum. So kind of think back to chapter 5, the present value chapter, and that's what we were doing. We're bringing everything back to today, future cash flows back to today at some rate of interest based on some number of periods. Okay, so this is 10%, 1 year. So I discount 10% at 1 year, I get 909. 60 at 2 years is 49.59. 80 at 3 years is 60.11. And then I add those up. This is the net. So I've got time 0, negative 100. I've got 3 futures at their present value. That's my present value. I add them all together. I'm netting the numbers against each other. I'm netting time 0 against all the futures to get 18.79. So that's the net present value. Excel, the formula is NPV, the rate, 10%, and all the cash flows. Then we add back the one cash flow we don't discount, CF0. Okay. So the goal is that this is positive. If it's above 0, if this number is greater than 0, I'm a happy camper. That's what I'm looking for. Okay, so it's 18.79. That's good. I want that kind of a number. Now we'll go back. I'm going to do a separate video that shows you how to do this in Excel. Okay, but we'll just kind of get through the slides first. And then I'll do the same thing for project S. Remember, S was more the short project. And same thing, same concepts here. Negative $100, all the various cash flows discounted. I get a net of $19.98. But what I want you to notice is 1879 for L, and the big cash flows were the last couple of years, versus S was 1998, and the big cash flow happened in year 1. What I want you to recognize is the further away you get from time 0, the greater impact discounting has. Okay, so the deeper I get for time and I bring some future amount back to today, the more that the time value of money will eat at that number and reduce it. Okay, so because in L I had the big numbers were in years 2 and 3, the time value of money really ate at those. But in Project S, I had my big payout in year 1, so that 1 year at 10% wasn't that big of a deal. It didn't discount my number as much. So I just kind of want you to recognize that. That's kind of how you can just kind of generalize the decision by looking at these cash flows. Okay, so 1998 was the bigger one. So if I could only choose between the two, if I could choose one or the other, everybody can see that Project S would be the winner. Okay, and of course they show us the calculator portion how to do this too. I'm not too worried about that. We're going to use Excel to do that for us. Okay, so the rationale of the NPV method, I've pretty much already explained it, but we take all those present value of the cash inflow, subtract against the cost. That's my net gain in wealth. So if I invest in this project, that's my net gain in wealth. If it was a $100 project, $19.98 over the next 3 years. If it was a $100,000 project, that's $19,980. So it's kind of a big deal. So what's nice about NPV is I know what that net gain in wealth is. So if these two projects were independent, meaning one does not affect the other, I could choose both if I had the funds, right? If I have the money to choose both and they're completely independent, both are winners. They're both above 0. If they're mutually exclusive, meaning I could only afford to do one, or they both are solutions to one single problem. The book actually has an example problem in it where it says, imagine that we're a factory and we're trying to figure out a more efficient way to move product through our factory. The two choices we came up with are assembly lines and forklifts, right? And so that's mutually exclusive. I can't choose both, right? Because my forklifts will be running into the conveyor belts, right? So I choose one or the other. I do the computations, I do the math, I do the analysis, and I choose the one that most likely gives me the highest NPV, right? So it's mutually exclusive. I'm looking for the one with the highest value. If it's independent and I can afford to do both, then I would do both. Okay. So the next one's called IRR, internal rate of return. So we're solving for a rate. So the answer now is a percentage. Okay. In the previous example, the answer was a dollar amount for NPV, but for IRR, we're solving for a rate. So look, the formula looks kind of familiar, and the calculation is all the future cash flows divided by 1 plus the IRR. And we do a sum of that, the number of periods and time 0 being today. So again, we could do this on a financial calculator, or we can do it in Excel, and we're going to do this in Excel. So Excel has an IRR formula, which is a super easy formula, which I'll show you in a separate recording. Okay. Now, what they want you to understand, though, is that IRR and yield to maturity are the same thing. Because think of a bond as a project, right? We know that a bond, if I buy a bond, I'm an investor in a bond, what I receive back are a whole series of cash flows, right? I spend money, times 0, money goes out the door. I receive then regular coupon interest payments every 6 months. And then I receive the principal from the bond back when the bond matures. It's very similar to a project, right? I invest in a project. I spend money today. I get a future of positive cash flows, that end at some point in time. So it's the same calculation. So just FYI, if that helps you understand it a little bit better, just think back to some of the calculations we did in Chapter 7. So the rationale then, the decision guideline for IRR is I'm looking for a return greater than the WACC. Okay, so in this example, if my WACC is 10%, that means as long as I invest in projects that give me a return greater than 10%, I'm golden, right? I'm good. And that's what I'm looking for. That will add value to my company. Think of a bank and think of what interest rates at banks are. If you are going to the bank and borrowing money for a car loan, 5 to 7% is all kinds of factors that determine what the rate you get is. New car, used car, how old the car is, your credit score, how much you're borrowing. But let's just say 5 to 7% would be the range that you would expect to pay on a car loan today. Now imagine you go to the same bank and say, I want to buy a certificate of deposit from you, right? Same story. The rate of return the bank will give you will depend on how much money you put into the CD, how much time you want that CD to grow, and so on. The more money you give and the longer you're willing to wait, the higher the return that you get back is. But compare the rates. Most CDs right now, 2 to 3%, depending on various factors, right? So the bank will pay you if you save with the bank between 2 to 3%. But if you borrow from the bank, it's going to be 5 to 7%. So and that's what banks do as part of how banks make money, is they're charging higher rates of interest than they are awarding as savings rates. It's no different than this, okay? So if my cost of capital is 10, meaning that's the cost of me obtaining capital to invest in projects, I then need to invest that in projects that give me return greater than 10. And as long as I do that, life is good. Okay, so that's all I need to do. So again, and the decision is the same thing. If it's independent or mutually exclusive, I have to decide that, right? If they're independent and I could afford to do both, I would, because both of these give us a return greater than 10. So both the L return was 18 and the S return was 23.5. So they both are significantly above 10. If they're mutually exclusive, I choose the one with the highest, which is S. If they're independent and I could afford to do both, I would do both. Just depends. Okay, so we talked about that. So I'm going to skip the NPV profiles and that. So I'm not going over necessarily every little thing, but I'm skipping that part. But I do want to talk next about reinvestment rates. So NPV method assumes cash flows are reinvested at the company's WACC. The IRR method assumes that cash flows are reinvested at the company's IRR rate. For projects S and L, they were like 23 and 18. So it says assuming cash flows are reinvested at the WACC, the opportunity cost of capital is actually a much more realistic example, meaning that makes the NPV method more realistic and therefore a better method to use than IRR. Now, in reality, it's best to just run all the methods and do them all. I used to do capital budgeting type stuff in the corporate world, and we would do all the calculations because you just never knew the questions you would get from management and decision makers. Let's just do all the calculations so we're ready. And usually, all of them corroborate each other too. They all kind of go together to suggest this is, all 5 methods point to saying yes or to no on a project. That just kind of helps you know you made the right decision. So IRR actually kind of has a hybrid version that might be just a little bit more accurate, a little bit better. And so it's called MIRR, Modified Internal Rate of Return, which is a little bit better measurement than just straight IRR. And the difference is MIRR assumes that cash flows are reinvested at the WACC. That's the big difference between the two. And so to do this, you have to find out what the terminal value of a project is. So terminal means end, right? The ending value of a project. So you compound inflows. Compounding means you're doing future value. If you recall from chapter 5, discounting is present value and compounding is future value. So I'm going to find the terminal value by compounding all cash inflows to that end value, and then do a present value from there. Okay, so I'll show you how that works. Once you see the picture, I think it'll make sense. So we'll go back to project L, and you can see here that I still invest the $100. I have the 10% return. I received cash flows of 10, 60, and 80. But now I'm pointing my arrows to the right. So I'm compounding forward focused. So 80 is 80, right? Because I'm trying to get to the terminal year, which is year 3. So I take that 60 and I go ahead just one period, right? So 60 times 1.1 is 66. Then I take that 10 and I go forward 2 periods. So $10 times 10% for 2 periods is 12.1. So the terminal value of my cash flows is 158.1. Okay, and then I use that number to calculate my MIRR, right? So then I do this calculation down here. $100 today equals the terminal value of 158.1 divided by 1 plus the MIRR. In this example, it's a 3-year project, so I have the 3 right here. That gets me to 16.5. Okay, so that's kind of the visual of how this works, and of course I'm going to have you do this in Excel, where there is a handy-dandy MIRR formula that we can just plug into and use, and this will happen for us pretty easily based on that formula. So just kind of keep that in mind too. That will help us significantly. Okay, so I've got the MIRR calculation there. And so why use it versus the IRR? Well, the MIRR assumes a reinvestment at the opportunity cost, which is the WACC, which actually is much more realistic. And managers like rate of return comparisons, and so MIRR is just simply better than that than the IRR calculation is. Okay, so then the last couple deal with payback. There's payback and discounted payback. Payback is a very simple one. It just basically says, if I invest in this project, how long before I get my money back? It's that simple. It's super easy. So how long before my money comes back? So all I'm doing is accumulating my future cash flows until the year the project turns positive. That's all. And it's a very simple calculation. The graph is right here that shows you. So I'll go back to Project L again. And so I invest today at time 0, $100. In year 1, I get $10 back, so I'm still at 90. In year 2, I get 60 back, so now I'm at 30. In year 3, I get 80, so between years 2 and 3, I go positive. So my answer is 2 point something. For sure, after between years 2 and 3, I get my money back. It's just a matter of how long between years 2 and 3 do I get my money back. And so the payback is 2 plus 30. The number here divided by 80. The key is you take that last negative number and divide it by the last positive cash flow number, or the last year's number. 30 divided by 80 is 2.375. Okay, so in 2.375 years, which is 2 1/4 of a year, right? It's just 2.4% of a year. I get my money back. Now Project S, remember that Project S had bigger cash flows early on. So its payback is shorter. It's 1.6. Okay, and so payback is good as a general rule of thumb. It's good to know what it is. It never hurts to know what your payback is, but rarely is it used as the loan method for making a decision. Okay, and the reason is it does not take into account time value of money, and it does not compute what the future cash flows are. We just care about payback and we stop. Okay, so it has some limitations. Now, one limitation can be fixed by using what they call the discounted payback. So I've got my cash flows just like before. That's all the same cash flows. But what I did differently this time is I took each cash flow and I discounted it using the time value of money. We're using 10%, so $10, 10% 1 year is $909, $60, 10% 2 years is $49.59, and so on. And these are the numbers that I use to do my calculation. So 100, 90.91, 41.32. I still go positive between years 2 and 3, just like before, but the number is going to be a little bit longer because I'm using smaller amounts here. So instead of, like this one was at 2.375, this one's at 2.7. So discounted payback will give you a longer time period. But it's probably a little bit better calculation because we should be taking into account the time value of money. So neither method is necessarily perfect. As I mentioned, kind of just a good rule of thumb. It does give you an idea of liquidity, right? A safer project gives me my money back faster. So 1.6 versus 2.375. You know, Project S was just simply a little bit less risky. So it's good to know that. So there's no downside to doing it. But the weaknesses, of course, unless you use discounted, the time value of money calculation is ignored. It ignores cash flows after payback. And there absolutely is no correlation between payback and wealth maximization. And if you can recall, I've mentioned previously that this class is very much about the decisions you make, that a company makes, to add value to the firm, right? So this method will not help me make that decision by itself. It'll help me maybe corroborate some information. So it should not be the only method that we use to do a capital budgeting decision. We should also be using NPV, IRR, MIRR, and so on. Okay. So they're just giving us one more example here to go through and work on. And this one says, I'm going to get an error. Why? Well, because sometimes that's the way it works, right? I've got a couple of negatives right here. And so why is that? Well, because I've got potentially multiple IRRs. And I don't get into that in the homework very much. So don't worry about the multiple IRRs too much. But just want you to be aware that might be an issue. Okay, so I'm going to end it right there. As always, if you have questions, let me know. There's another video also that will kind of show you how to do some of the calculations using Excel.